I'm Chelsea from the Truro Council on Aging, and today with us we have Larry Dapsis. He's an entomologist with Cape Cod Cooperative Extension. Hi Larry, how are you today?
Chelsea, it's great to be with you guys. I mean, I wish obviously we were all together in person, but this is the way we'll be doing business for a while. But I'm happy to kind of bring I think some interesting information to this particular project.
Yes, and we appreciate your time and you doing this with us today via Zoom. So thank you very much. We appreciate it.
Excellent. So why don't we start? I'm going to open my presentation.
All righty.
And today it is the world of pollination. Okay, very good. About 90% of the Earth's plants require pollination. And basically this involves mechanically moving pollen from the anthers, which is the male part of the flower, to the stigma, which is the female part of the flower that grows the fruit. And in some cases, this is done mechanically. So crops like rice and wheat and corn, this process occurs by wind. They're wind pollinated plants. But a lot of plants require some agent to physically do this. And in many cases, it involves insects. And there's a number of insects that participate in this process. So obviously butterflies love to visit flowers and will transfer pollen. A number of beetles feed on blossoms. They feed on the pollen, and they also transfer pollen to the stigma of the flower. This is not a yellow jacket. This is actually a hoverfly. It's actually quite a beneficial insect. And they are attracted to blossoms as well. Now, there are other flies. This is a biting midge. And while biting midges don't on the surface seem like you'd want to see them in this domain, but this little guy, they're about 3 millimeters long. And basically, they are the only ones that can pollinate cacao blossoms. So for you chocolate aficionados, this is a really important creature. All right, but bees, with their big, robust, hairy bodies that pollen sticks nicely to, they are perfect for this activity. But it's not just insects that are important in its process. There's a number of bats that are key pollinators for a number of plant species. And here's an agave plant. And this agave plant, or this flower, is exclusively pollinated by bats. And agave is the plant from which we get tequila. So the next time you're having that margarita, raise a toast to the Mexican long-tongued bat. All right, beekeeping, big business, but a very popular hobby amongst lots and lots of people. And they love beekeeping, and they're always looking for ways to celebrate their craft and share it with the general public. And it's really cool. But bees, honeybees, are having some big problems. But let's take a little trip and look at different aspects of bee biology. Bees and people, we see the world in a very different way versus bees. Our vision kicks in at about the portion of the spectrum that starts at red and goes out to violet or purple. But bees do not see red. Bee vision kicks in at the orange part of the spectrum, but it extends beyond violet into the ultraviolet. Now, we are awash in ultraviolet light. It's all around us. We just don't perceive it. We do perceive its effects occasionally, like sunburns, but ultraviolet light is used by plants to communicate with bees. So here's a daylily, and the picture up top, that's how a blossom appears to people, okay? But with this ultraviolet light aspect of this, the plant reflects different levels of ultraviolet light. So the darker and darker the purple in that blossom, that's a higher saturation of ultraviolet light. And so the plant has evolved to communicate with bees, telling the bee that you go to the darkest, darkest purple part of that flower. That's where the pollen and nectar reward is found. So these are what we call nectar guides. And nectar guides are found throughout the plant world. So bees and plants have been talking to each other for millions of years. All right, so honeybees. All right, who lives in a colony? Well, on the left, you have a queen, and you only have one queen, and she doesn't build comb or go out and forage. Her exclusive job is just to lay eggs, and she lays about 1,000 eggs a day. In the middle, the bulk of the hive consists of workers. These are the daughters of the queen. And in a colony, you might have 30 or 40,000 worker bees, and they do everything. When they first emerge as an adult worker bee, their job is to clean the hive. And so they emerge, they look around, there's quite a mess, and it's their job to clean it. How unfair is that? And then as they get older, their jobs change. They get a little bit older, they become nurse bees and take care of the kids. Then they get to a point where they're building comb and capping brood. And just before they become foraging bees, they become guard bees, and they're stationed at the entrance to the hive to protect it from predators. And then on the right, during the summer months, they produce drones. These are the male bees, and they don't really do anything. They don't forage. They don't participate in hive activities, and they basically just go out and they swarm with other drones, and they mate with virgin queens that have emerged from hives and are looking for a new colony. And at the end of the summer, the worker bees kick those drones out the door to starve or freeze. Because who wants a bunch of guys just sitting around all winter, drinking honey and not participating in any household chores? So the society of honeybees proceeds in a very efficient manner. All right, bees communicate a lot through the use of chemicals we call pheromones. So here's a queen bee in the center. She's got that red dye on her back. And what she's doing is distributing a pheromone to the worker bees, a queen mandibular pheromone. And the workers in turn will share it with other workers and distribute it basically through the whole hive. And that's telling the worker bees a few things. Mom's home, mom's healthy, and laying 1,000 or more eggs a day. And this is a powerful pheromone. It has the effect of keeping those bees all glued together as a structure. They will basically surround the queen and keep tending to her needs as they go about their activities. And this queen bee mandibular pheromone has been synthesized and put in controlled release dispensers to support research. But this controlled release dispenser is the device that's used at a very popular event at a number of county fairs, the Bee Beard Contest. So you strap that controlled release dispenser to a part of your body, and the idea is to see who came up with the nicest or most clever looking beard or structure. Now this looks dangerous, okay? Who wants thousands of bees on their face or head? But this is a rigged game. Just before they release the bees for this, they let them drink as much sugar water as they can imbibe. And this has the effect of having like a big Thanksgiving dinner. You don't want to be aggressive. You just want to sit on the couch and watch some football. And here's a person that took this bee beard contest to an entirely new level. He built himself a bee suit, and this took about an hour to do. And that man, he's standing on a scale, And that bee suit weighed 57 pounds. And if you do the arithmetic, that works out to be over 250,000 bees that was on this guy's body. And when they're done, they just scrape the bees down into buckets and put them back in the hive. But this is pretty impressive backyard activity to consider. All right, there are other pheromones. Bees live for about a month, and sometimes they die out in the field, but sometimes they die in the hive. And when a honeybee worker dies, she emits a funeral pheromone, and the other workers around her will perceive this pheromone and conclude, okay, Gladys is gone to meet her maker. It's time to get her out of the place. So they basically take Gladys out the front door and boot her out, where she is then scavenged by predators like yellow jackets. We talked about bees having different tasks when they get older, and I mentioned guard bees being stationed at the entrance. And creatures like yellow jackets patrol around hives pretty frequently. So yellow jackets and hornets, and they're basically testing or probing the strength of the hive. You know, how aggressively can it be defended? And if they sense that the hive is weakened by something like disease or whatever, they'll recruit other members of their species, go in and rob the honeybee hive. So they'll take all the honey, they'll take all the kids and feed them to their kids. And so when a yellow jacket or something gets too close and a guard bee decides this is a threat, it will attack the yellow jacket. And when she does, she emits an alarm pheromone. And this is perceived by the other guard bees to join in the attack. So it's like a gang tackle in football. So a very, very useful way of protecting the hive. Now, this alarm pheromone has also been synthesized and has a really interesting application. This alarm pheromone is being used in Africa by farmers as a repellent. Well, what the heck would this repellent be repelling? It repels elephants. As it turns out, elephants have very, very sensitive skin around their eyes, and they don't like bee stings at all. So they get a whiff of that alarm pheromone, and they are out of there. And you can picture, a few elephants in a cornfield overnight could do quite a bit of damage. All right, what's going on with bees? Well, there was a phenomenon that was being observed by beekeepers. They would open a hive and it would be completely devoid of worker bees. There would be a queen, a healthy queen, capped brood. So it looked like the workers just got lost, forgot to come home. And so this was described in about 2006. And this is high stakes poker, with this threat to the industry, because in the US alone, fruit and vegetable production is worth $20 billion because about 90 crops are pollinated by bees, a lot of different fruits and vegetables. And so basically 2/3 of the food that you put in your mouth was insect pollinated. And just before 2006, a new class of insecticides was introduced to agriculture, the neonicotinoid insecticides, neonics for short. And one of the characteristics of neonics is that they are very, very toxic to bees. So people were putting two and two together and were wondering, are the neonics the smoking gun involved in a CCD? Well, also CCD is now been expanded to honeybee decline, a much broader category because there are some other problems that are leading to these conditions. So CCD is a subset of the decline. And if you look at that vertical dashed line, 2006, that's when this phenomenon first described. And this is honeybee inventories. USDA up until recently would take inventory data to find out, okay, how big is this industry? What are the trends? And in spite of colony collapse, you can see that honeybee hive levels remain steady. But the only way that line is remaining steady in terms of 2.5 million hives or so is because beekeepers are forced to requeen their hives. So it's a very, very expensive proposition here. So there was circumstantial evidence, so that led to a deeper dive into the neonics. So looking into these and trying to determine, should they be more restricted, or should there be applications that they're not appropriate? Should they be taken off the market entirely? Okay, so all those questions were there. So one of the properties of neonics is that they are systemic. So it doesn't matter what part of the plant they're applied to, they wound up being translocated throughout the entire plant. So you drench the root system, and that'll go up through the xylem tissue. So the xylem and phloem of the vascular tissue of all plants. And so it's redistributed to the foliage, the growing point of the shoot, and even it gets into pollen and nectar, which is a big concern. So who uses them? Well, they're the most widely used class of insecticides in agriculture, but they are available to homeowners, okay? And if you want to know what a neonic is, you go to any garden center, and anytime you see a product that says annual treatment or systemic, those are neonic products. And as I talk to people that are gardeners, I basically try and wave people off of this class of insecticides. People are really not trained in the application of pesticides. And in these products, you can overdo things and cause a lot of problems. The other concern I have here is that these are highly soluble and mobile in soils. So with our very sandy soils here on the Cape, there's definitely a risk to groundwater contamination here. So I tell people that for every pest problem that you may have in your garden or on your shade trees, there are alternatives to these products. Don't use them. And it's almost an industry that is being self-regulated. Box stores like Home Depot, they're telling their suppliers of bedding plants that we will not buy your plant material if it's been treated with neonic insecticides. And so there's a lot of information that's being pushed out there to garden centers and the general public. And there's even some local action that's taking place. Highness Country Gardens, they took those products off the shelf entirely. Okay, why neonics, and imidacloprid here is the most widely used neonic, why it doesn't completely fit the CCD picture, okay? For one thing, we know that if beekeeping equipment is treated with radiation, that CCD effect vanishes. So this strongly suggests that a pathogen, something like a virus, may be possibly involved as well. So it doesn't let the neonics off the hook, but it just suggests that there may be two smoking guns. Australia is another example that's pretty interesting. Australian agriculture uses lots of neonics in their production of food. And there has not been one single case of colony collapse disorder down under. So what's the big difference between Australia and North America? Well, in Australia, they do not have varroa mite, which is a major parasite and a huge problem up here in North America. So that parasite seems to be another smoking gun. Other things to think about. Nutrition. We know that if you take bee colonies and put them in a place where they only have access to one type of pollen and nectar, those hives are not as healthy compared to hives that have had access to a variety of different sources of pollen and nectar. Travel stress. Yeah, this is a big one. The beekeeping industry, it's migratory in nature, and bees are moved all over the country. And this process starts around February when California almonds are coming into bloom. And because of the popularity of almonds in terms of the market and how it's grown, California almonds has grown from about 300,000 acres to over 1 million acres. And that requires a lot of bees. So basically half the bee supply moves into California during the month of February for about 4 or 5 weeks. And from almonds, they then go to the Pacific Northwest for tree fruit crops like apples and peaches and pears and small fruits like blueberry and cranberry. North Dakota, they have about 600,000 acres of sunflower that require bees to pollinate it. The upper central Midwest, Wisconsin and Michigan, yeah, tree fruit crops and again, cranberries and blueberries. And the same in the Northeast, New York through New England, tree fruit crops, cranberries and blueberries as well. And at the end of the pollination season, they either go down to Texas or down into Florida, and where they're given a chance to rest until the following February. Genetic diversity, and this is something it's difficult to wrap minds around, but the genetic stock for queen bee production is very narrow, and that's because USDA has basically limited the importation of bee material for breeding for fear of introducing new pathogens or parasites. So as a result, you get a narrow set of genes, and now the problem is that if something exotic comes in and this genetic stock is not resistant to it, it creates huge problems. And there's a variety of pathogens and parasites. I mentioned varroa mite, but there's a number of diseases that affect honeybees as well. This is varroa mite. Yeah, it's like a big tick, and they don't feed on the blood of the bee, but they suck out the fat body of the bee, and that weakens the bee considerably. So varroa mite can really weaken a hive and make it more susceptible to various diseases. And this is probably the #1 problem in the United States right now. So beekeepers, both professional and hobbyists, really have to be on top of their management game to keep this thing under control. All right, honeybees. There are big problems with the industry, but there's nothing we can do on a local level to impact the problem materially. This has to be played out at a much higher level. Federal agencies, academia, all working together to figure out, okay, how do we collectively solve this problem? So for hobbyist beekeepers, you really can't do anything to affect the big picture. So let's turn our attention to wild bees, like things like bumblebees. Well, we've had the advantage here in southeastern Massachusetts of Henry Franklin. Okay, Dr. Franklin was the entomologist at the Cranberry Experiment Station in East Wareham for 50 years. And he worked out all the life cycles of the major pests of cranberries and figured out ways to manage them. But he had a strong interest in wild pollinators, particularly bumblebees, because cranberry growers will tell you that bumblebees are a superior pollinator compared to honeybees, just because bumblebees basically co-evolve with ericaceous plants like cranberry and blueberry. So they understand that blossom. They know exactly how to make the most use out of it. Henry was a great man, and at one point, I was the entomologist for the ocean spray cranberries. I was the bug guy for North America. And as I was working on particular cranberry pest problems, there were days I wish I could have a seance with Dr. Franklin to kind of help guide me. All right. One of the things that has really been severe in terms of occurrence is we've lost 50% of our bumblebee species, bombus species. They're either outright extinct or they're very, very rare over the last 100 years. And if you do a deep dive into the reasons for this, yeah, it's a variety of smoking guns, parasites, diseases, pesticides, and significantly a lack of forage, a lack of flowers. And this is something that we can impact. And it's not just the number of species of bumblebees, but we've seen a shift in the dominance of particular species. What, after Henry Franklin, that position has been now occupied by actually my best friend from graduate school at UMass Amherst, Dr. Ann Averill. And I convinced her to come and join the cranberry industry. And so she's been at the Cranberry Experiment Station now for about 30 years. And she has carried on the torch in terms of research on wild pollinators like bumblebees. And one of the things she has seen over the last 20 years is that Bombus impatiens back in 1990 used to represent about a third of the species of bumblebees that were out there. But today, Bombus impatiens represents about 2/3 of what's out there in the field. And again, if you look at the problem from susceptibility, if there's something introduced to this region where Bombus impatiens is particularly susceptible to, that is a huge problem. All right, bumblebee nests are completely different than honeybees. Bumblebee nests are 1 year only, and they're not nearly as big as a honeybee hive. They may have about 300 workers at their peak. And so at the end of the summer, they produce new queens for the following year. And those new queens, they'll find and get under some leaf litter, they get snow cover, and they just tuck themselves away for the winter. And then they emerge in the spring, early spring, about the time first flowering plants are out there. And they'll form nests. Usually an abandoned rodent burrow is a pretty good place, but they'll also make them in dead grass. And what they do is they form these capsules out of pollen and nectar and lay their eggs in there. And so you see this broken capsule, and those little maggots are the larvae of the bumblebee. And in the spring, when conditions are very cold, the queen bumblebee will even sit on those capsules, and she can vibrate her wing muscles to generate heat. And she can get her body temperature from ambient up to about 90 degrees in a few seconds, because she needs to do that in order to allow her to fly. So, but she also incubates her little children. All right, people have tried to figure out for many decades, how can you domesticate bumblebees like honeybees? And people have come up with tons of ideas for nesting boxes, and bumblebees just never, ever cooperated. Well, a company in Holland, Cooperative, they figured this out, and they sell bumblebee hives, these quads. So it's 4 units on a pallet. And I've met people from Cooperative at professional meetings, and it's all proprietary technology. They don't talk about how they do this at all, but I would be absolutely fascinated to see how they figured this out. And these are used in a lot of high value crops. One of the popular or good markets for them are greenhouse tomatoes. And instead of having workers with little paintbrushes transfer pollen to the various parts of the plant to pollinate it. And they calculated that a single bumblebee is worth about $5 of tomatoes. And it's used in some other high value crops, so berry crops like strawberries. So we even have one grower on the Cape that uses them at a U-Pick blueberry farm in Dennis, Holcomb Rock Farm, Beautiful, beautiful farm if you ever get a chance to get out there. All right, here's a honeybee on a cranberry blossom, and she's working that blossom, and she'll do enough searching for nectar, but those pollen grains are really fit up tight in those anthers. Whereas here's a bumblebee, and the difference between a bumblebee and a honeybee, the honeybee kind of, probes around and might get enough pollen on it to affect this transfer. But when a bumblebee visits a blossom, it holds the blossom and then vibrates those wing muscles. And that sends out basically a sonic vibration. And that just unleashes all that pollen completely. So they just, clean it out. So bumblebees are way more efficient. Honeybees can get it done. In fact, cranberry growers will bring honeybees in to supplement the bumblebees. They bring in about 2 hives per acre. But when farmers see bumblebees out there, they are very, very happy. All right, what can we do? Yeah, we can plant the forage they desperately need. When I drive around the Cape and I see perfect green, lush lawns with no clover, no dandelions, I grimace. That's a lost opportunity. And because I know the type of chemical inputs that were required to make that perfect lawn, in my lawn, if it's green and grows, it's welcome, and especially if it blooms. It's hard to believe that clover is considered now to be a weed problem, where white clover used to be part of the standard seed mix for grass, but not today. So you have to want the clover. And it's not just planting things that come into bloom. Like if you look at the upper left, those are chives. And if you've ever seen chives come into bloom, that is like a bee magnet. Same thing to the right with basil or mints and things like that. So there's a variety of, herbaceous and trees and shrubs that should be part of the landscape. Now, the trick here is that you want season-long forage. Okay, so you want plants that come into bloom early in the spring, late spring, early summer, late summer, into the fall. So season-long. And so you can go to garden centers and they can certainly guide you on what's the best variety of plants to help accomplish this. But Xerces Society, they've got a lot of good information about how to develop pollinator-friendly gardens. And this has been extended in some creative ways. This is again in Holland, where these are bus stops, and they've created basically rooftop pollinator gardens to support urban pollination. All right, Bern Heinrich. He's a naturalist that lives in Vermont. Brilliant, brilliant man. And he actually penned one of my favorite bug books of all time, Bumblebee Economics. So if you ever want to do a deep dive on how fascinating these creatures are, this is the book for you. I refer to this book all the time. And so with that, we will find a way that we can get your questions and address them. So with that, I thank you.
Thanks, Larry.
You're welcome. My pleasure.
We're so happy you were able to be with us today. Thank you so much.
Excellent.
And you take care.
Thank you.